So this is another exercise to find points of inflection for a function. What are the points of inflection for this function? This requires a lot more work because the first and second derivative are not easy to find. But see, let's see what happens with the first derivative. This is thought of as a product of two functions. So if I have to differentiate, I need my product rule. I first differentiate my x and keep my square root of x plus 3. Next time around, I keep my x and differentiate square root of x plus 3. That will be half of x plus 3 to the minus half. Now, you will think that, oh, maybe I'll just leave it like that and continue with product rule. That will be okay, but simplification for the second derivative might be something horrible. So you might want to simplify now. So if I were to simplify now, say suppose I see that the common factors are x plus 3 to the negative half, right? And if you want, you can actually take out a 2 on the denominator so that you will be dealing with just integer values, right? So if I take this out of this, I will get x plus 3 times 2. Otherwise, you don't believe, you multiply these two together and see whether if you get square root of x plus 3. So this is a difficult part most students struggle with, is factoring things like that. And so what about this? This one is a little easy because I have taken this out. I've taken this one out. And what is left is just a plus x. So it's going to be plus x. Now you can see the simplification is 2x plus x. That will be 3x. So it's 3x plus 6 on the numerator. So that one can go down and become 2 square root of x plus 3 on the denominator. The numerator can be simplified to be 2x plus 6 plus x. And if you simplify that further, it's 3x plus 6 over 2 square root of x plus 3. So if we have to find the second derivative, we really need quotient rule because there's nothing much we can do. So remembering what this is, do a low d high minus high d low, we will get, whoops, low d high. D high will be the derivative of 3x plus 6, and that's just a 3. Minus high. D low. D low is a little hard because low is 2 square root of x plus 3. So if you differentiate that, it will be 2 times a half times a x plus 3 to the minus half. Okay, we need to deal with this. Otherwise, we will never be able to find a PPOI, and we will not be able to settle the question on where is it concave up, where is it concave down, and whether the PPOI is in fact a point of inflection. So we need to do what we did a moment ago. Firstly, there is cancellation. There is cancellation, this and this, right? And then look for common factor. The common factor will be, we can say 3 is a common factor, which in fact it is. And the lower power of x plus 3 will be another common factor. So if I do that, 3 is taken out. And x plus 3 to the negative half is also taken out. The denominator kind of looks like that, 4 times of that. Because you have to distribute your square. And if you do that, what's left on the first group is clearly 2 times of x plus 3. So this is where most students struggle with. And we don't believe multiply x plus 3 with x plus 3 to the negative half, you should get I don't know how to get rid of that. You should get, so, alright, you should get, whoops, 2 times of x plus 3, right? And the other one is much simpler because 3 is taken out, and so you get a x plus 2, right? And the rest has been taken out. So this thing here can go to the denominator. It contributes to the denominator. And if you do that, it becomes x plus 3 to the 1 plus half. So 3 half. Right. And the numerator is actually 2x minus x. So let me just write it down in detail. 2x plus 6 minus x minus 2. So it's kind of like a x plus 4, right? Alright, so what are the PPOIs? Maybe you think negative 3 should be a PPOI because it makes this 0, so it makes f double prime undefined. And maybe you realize that here's another one, negative 4 is another PPOI because it makes the numerator 0. However, if you look at the original function is this. And so this function is only defined when you have numbers bigger or equal to negative 3 all the way to infinity. Because if you have anything less than negative 3, this will be negative. And you cannot take the square root of a negative number. So you can see that the only PPOI is negative 3. But you don't want something on the boundary to be a PPOI. So this function has no point of inflection. So you have to cross both of these out because they are not in the domain of f. And if you try to draw the table, it is not a vertical line contributing to the table. So the function has no point of inflection. Whoops. And that's the conclusion.